So we're going to go over a little bit on automation. Before we really get into what we're going to cover and the different topics, just for my information, who runs automation? Okay, so pretty much everybody here. So as we go through it, just think about maybe some operational stuff. I get it, it's been like 6, 7, 8 months. So we don't always remember the settings, things that we did, but I can probably be certain that you'll remember a few little hiccups you had along the way. So as we're going through it, just think about that, and maybe as we are talking about some operational stuff or some settings, think about that and bring it up as we go through. So quickly, before we start into maybe some settings and how do we optimize it, what are we really looking for? The first thing that I want to look at is what are some visuals that we're going to be seeing? What do we want to know from a relationship with the funnel fills? And as well as how do we relate that into some operational things. So the first real thing I want to look at is on our 1200 here, these points here they're always visible. But on the 700, which is what the rest of you guys have, when do we see them present or here on the display? And then once they're there, what are they there for? Just because? Have we even noticed it?
Well, as far as grant
Just these indicators right here, not the funnel flows. Just these indicators right here. What? Theoretically? What did you say? What?
Target where you agree with the machine, what the machine's doing.
Yeah, so these marks here, these 3/4 marks, are actually, you can think about them as trigger points. So if we're going along and let's say we're running on our funnel fill, if we're going up, and we can just stick with SIVLOS for pretty much all of this, because that's an easy one to identify. If we are going along and the funnel fill crests along that point, that's when it identifies and says, I have a problem, I need to make a change. So thinking to how would we normally run our machine without automation, and we'll get into why our funnel fills are a little bit different now with automation. So non-automation machines, we can think back to 30 series, 40 series, even 50 series when we don't have automation on. Where do we typically want to see that funnel fill? Where do we want to see our funnel fill here? What do we typically do? At the bottom? As low as possible. As low as possible. So if we're running along here and we're running as low as possible, and I just said this is a trigger point, right? Our trigger point is 3/4 of fill right here. What needs to happen before the combine will make a change?
Trigger point.
So it needs to fill all the way up to here, then crest this before it'll make a change. So in some scenarios, depending on our adjust frequency, that could be a minute before it even makes a change. But what if it takes 4 or 5 minutes to even get to the trigger point, and then another minute to actually make a change? That's 6, 7, maybe 8 minutes before it actually did anything. And in most scenarios, what have you done within that time frame? Or probably turned around a couple of times. So maybe I went down and it took me 5 minutes to get to the pass, and right at the end of it, it got to here. Then I went ahead and I turned around. And the next pass, it started down here and it came all the way up to here, but it never got across here the entire time we were experiencing SIVLOS. Well, what do we think in that scenario? Well, automation never made a change and I'm always experiencing SIVLOS. Well, what was the reasoning for that? Well, because we didn't have our funnel fill all the way up here. So the point that I'm trying to make is in normal operation, we got to have a different understanding or a different view of what our funnel fill should be. So if we want to have our automation making changes more frequently or have a higher response time, we're going to want to keep that funnel fill as close as we can to this point right here. Because that way, if it makes a change, it only immediately will be maybe a minute, 2 minutes, if it's bouncing above and below it, of seeing the issue. Whereas if we had it on the bottom, it needed to go all the way up, which took 5 minutes. So we experienced SIVLOS for maybe 5 minutes, which could have been 40 bushels to the acre. If you were targeting, let's say, 1 here, and it rose all the way up here, it could have been another 40, 20, whatever the scenario is, of experiencing that to come up here, and then maybe never press it in time, or we experience it longer than we needed to. So to ensure that it's actually making a change and seeing it, we want the funnel fill at the top. And then to make sure that it's being as responsive, we want the funnel fill at the top. So just a little bit of a deviation than what we're used to is just try and keep it right here. Okay, if you see it, let's say we're running along, another thing to note is if it's here and it's bouncing above and below it constantly, that's fine. That's actually good because that's as close as you can to where you want it. Well, now the next question is, well, how do I get it to this trigger point and have the outcome that I want? So I'm going to go ahead and I'm going to click the sieve loss here. We're going to kind of move over to it. Is we're going to make adjustments with our adjust frequency, or our sensitivity here, sorry, with our slide bar. If we had automation running, you would see the Moore's allowed, acceptable, too much, and way too much. And all you're doing to get that at the trigger point is adjusting the sensitivity. I just want to point out though, we aren't just adjusting the sensitivity to get it there, we are still physically getting out of the machine, verifying and quantifying the sieve loss, looking at the tank, validating that we have broken grain, mog, whatever it is, rotor loss, so on. And then, when we identify an issue, the result is by adjusting sensitivity. So we still need to get out and we still need to do it. Because if all we're doing is trying to hit our trigger point there on that funnel fill, if that is our simple goal, well, I can do that really easy, right? I'll just go ahead and I'll raise this all the way up, or I'll lower this down to the trigger points there, but I have no idea, once I do that, what's happening. Because if I just simply go off of the funnel fills only without actually justifying or validating the issue, we could go ahead and be sending 20, 30 bushels out the back, meanwhile my funnel fill is reading perfectly fine, right? So, second thing here is not only do we need to make sure that we are at that trigger point, but we actually need to get out and validate, is this an issue? Is this not an issue? Do I need to raise the sensitivity? Do I need to lower it? So another little bit of a deviation from our non-automation machines and how we traditionally would have run it. In the past, we would have just gotten out, once we saw it, we went up there and we made a change in the machine. We're still needing to get out and do that first step of identifying the issue. The difference with automation now is rather than making that adjustment and testing, do I open the upper sieve 1 millimeter, then testing again 2 millimeters, and so on, rinse and repeat. We go ahead and we say, hey, we have a problem with sieve loss by raising the sensitivity, and then the machine does the testing for us. It tests 3 different set points on the sieve. It tests the changing of the paint fan, and so on. But the first part, again, of getting out, checking, validating the issue is still very much true. Cannot forget about that with automation. Moving over, I do want to talk about something else here, referring to our funnel fills, kind of a third operational thing that I think trips us up a lot. So not only do we need to make sure our funnel fills are at the trigger point, actually getting out and validating the issue, but another deviation from a non-automation machine. So let's say we're going along, sticking with our sieve loss scenario, and we're going through, and we have our trigger point fine, it's at the 3/4 fill, we're going along, and we see that rise, even if it's just for a second. What's your first reaction? Naturally, what do we want to do when we start to see sieve loss go up?
Calm by.
Yeah, keep calm. These losses are fine. Losses are perfectly fine. We're okay. But what is our first reaction?
Open your sieves.
What?
Open them up.
Open our sieves. Make an adjustment, right? We went up here and we made an adjustment. So let's say in that scenario, that's exactly what we did. It got to our trigger point right here. It went up, but before automation can make a change, we decided, well, we're going to open up the upper sieve. So in this scenario, we're at 15 millimeters. We, let's say, opened it up to 18 millimeters. So we raised it by 3 millimeters. And the result is it went back down to a desirable range right here on our trigger point. So everything's happy, everything's running good, the funnel fills are where they need to be, and everything's fine, right? Everything keeps going and nothing changes. That's not actually what happens with this. So the reality is, as automation is running and we have automation active, it's going through and it's saying, is my rotor spinning at the speed that I think it should be? Are my cage vanes in the position I think it should be in? Is my pre-sieve at the clearance I think it should be? My upper sieve, and my lower sieve, and so on, and all the features that it controls. So when it goes through and it does its checks and it gets to that upper sieve and it sees that's at 18 millimeters, what does it do? It says, that's not where I left you. And it closes it down to the 15 millimeters, which caused what? sieve loss. So what do we experience as the operator again? So then what do? We open it back up to 18 because that was our first reaction, and the funnel flow goes into the right spot again. Well, then what happens? And then we do what? Exactly. And then we shut automation off, and we say this thing doesn't work. So in normal operation, when we experience that, what should we really be doing? What should be the operational practice there? Rather than making it on the armrest, we should keep going for a while, let this rise above the trigger point, and make sure automation is the one that's making a change. If you want to know, hey, is it actually making a change? What did it make a change to? In this scenario, if it's sieve loss, you'll see the upper sieve, or maybe our cleaning fan, highlight blue, and that'll be the indicator of what it's making a change to. But when we're running automation, we need to get in the habit of just this armrest right here. It just looks good in that scenario. That's all it's there for. It just looks. It looks cool. We can rest our arm on it. But we have to let automation make the change, because otherwise we're going to be sitting there fighting. If we're the ones that make the change, automation will just set it back to what it thinks it should be at and run from there. If we want to have those settings to be saved, to have the correct outcome that we told automation we wanted, we need to let it rise above here for a specified amount of time and let it make the change. Now we'll get into, well, maybe it's not making the change quick enough. There are 3 settings we can make in the background once we get into that, of how we can actually dial that in and make automation a little bit more responsive. Any questions so far? Three main operational things that I really think we kind of overlook a lot, and they're big deviations from a not automation or running it in manual.
What would need to be so high before it's going to change what you said?
Yeah, you're going to get into that in a second here. So in reference, guys, this is your sieve load configuration. If you don't see it on your 700, that's because in the cleaning tab, could be wrong on that, you have a sieve load configuration that will allow you to get rid of it. On the 1200s, this is visible. And maybe I didn't say this right at the beginning. Everything we're covering here on automation for a 700 is exactly the same as what we're talking about today with the 1200. I'll point out any key differences, but the logic and all the options are about 99% the same. But back to our sieve load configuration right here. So what he's saying, is there a sieve load or a maximum that it's going to do before it makes a change? And the answer is yes. It's these indicators right here. So if you look here, there's some misconceptions on this. We'll start with that. Some people have said, turn on its side, it's your left and your right distribution. That indicator, no, it's not true. We can see left and right distribution, and I'll show you that in a second. But all this is doing is telling you an average of our total sieve load. So how is that working? Maybe we'll start there before we get into some more visual and operational how it's working. What's new with the 250s and now 260 automations? So let's use my phone here as an example. So if you're looking, and let's say that we're going along, and this is my upper sieve. At the back right and the back left, above and below, there is an air intake. A single sensor here and a single sensor here. And all it's doing is measuring pressure differential, and that's how it's determining load. So there's an air intake and an air intake with a sensor here measuring the airflow that's coming off of the cleaning fan through our sieve. So let's say in this scenario we're going through, and on the right side we see a pressure differential. It displays in Pascal. 10 Pascal on the right side and 3 Pascal on the left side. What would that be a good indicator of? Right side heavy. Right side heavy, so if you're wondering how do we see that, run screen 5 comes on our 1200s. You can add it to a run screen on the Pro 700, but we have our indicator right here. So the whole thing and how it's determining what is our sieve load, how is it working, is just simply through pressure differential above and below the upper sieve, on the right and the left side on the tail end just before our loss sensor. After we're done here, if you don't know what I'm talking about and you want a visual, come find me and I can point it out to you. But on here, we can take it one step away and get back to your question. well, how do I use this from just a setup standpoint, not even with automation, is another good thing I like to point out with this. So if we're running along, this is flat level ground, not side hill, because that'll throw all this kind of out the window. This is flat level, we're starting off. And we go back to IC10 and IC3 here. That was a good indicator of we're overloading the right side. So what would I do with these numbers? How is that helpful? Well, what about my sieve offset? So the nature of a single rotor is what all the time? It's right side heavy, right? Because our first threshing pass is that front right. That is the first threshing pass. So that's where all the material starts to build up, and then when it comes across the grain pan onto our upper sieve, it typically overloads it. So what you can do here is if we see that, and let's say we see this again 10 and this 3, we'll put an offset lowering our left side until these numbers are as close as possible. That way, how have we done the offsets in the past? Getting out, going, checking from behind, going and doing our offsets, coming back, running it again, and then seeing it and getting out by checking losses. This way, we can go ahead and we can balance it as close as possible from the cab and then get out and do our final checks afterwards. But at least it saves us a few trips up and down the cab. Anyway, I kind of got a side note off of automation here. We're running back here, coming back to our overall, now that we know how is it determining sieve load and some of the background features of it, what is this telling us? So through the differential pressure, it's saying on this top mark, we are as loaded as we can without being overloaded, and this bottom mark is we are underloaded, the least amount of load with some level of efficiency. So in normal operation, ideally, you are above this mark and below this mark. Preferably what I like to see is as close as we can to this without overloading it and creating sieve loss, because why would I not put as much load on my sieve as I can? Because if I am underloading my sieve, I'm leaving what on the table? Capacity. Exactly, capacity. So we want to try and load the sieve as much as we can while having the least amount of losses. And this will be a good indicator. Now if you're running automation and it starts to see that it's overloading the sieve, adjustments will be made to correct that. But that is also a good tool that you can run with. On the 1200s, it's up all the time. 700s, it's only visible if you have it configured and automation is on. But it's a good indicator just to tell us where our siev's at and if we're leaving capacity gains on the table.
So on that bar, is that the top sensor or the bottom sensor?
Well, so there's only two sensors. There's left and a right, and then there's a top and a bottom air intake. And you'll see the air intakes, those are visible from the inside, and then a blue line that goes into a sensor on either side. So this indicator here is simply an average of your right and the left, and then overall sieve load.
If you're going to do an offset, how big is an offset?
Typically speaking, when we're doing these offsets, let's say we go back to that 10 and that 3, I like to do it at 0.1 of a degree at a time, maybe 0.2 if it's extreme, because we don't want to overdo the offset, because then all we're doing is transferring the problem of overloading the right to the left side and vice versa. So typically I like to do small increments at a time. That way we can get it the first try and then we don't overcorrect and have to come back.
When you're doing automation, does it offset?
Not at this point in time, no. The AF series will, but not on the 260s. Any other questions? Okay, so a few main points that I really like to hit. Like I said, the 3 main points of transfers from running it in manual to the automation, understanding of what our sieve load is, and then I'll point that out in a little bit. Any questions on how we do our sensitivities, or do you want me to dive in deeper of, well, how do we make the machine produce the outcome that we want? Does that make sense of adjusting sensitivities to produce the outcome we want rather than making changes on the armrest?
How long do you wait? It doesn't adjust to where you want it to.
So that is a good question. We're going to get into that in the settings. So there's going to be 3 different settings that you can do, and you need to know or understand the time limit on each one. I would say as a general rule, if it's more than a minute as a whole, we should probably go ahead and make some ranges or some sensitivity adjustments to begin with, or simply get out and validate. Because there are times where you're running along and this is going and it's up in the red on our sieve loss, the reality might be that it's going up in the red because our sensitivity is simply too high to begin with. We need to get out and validate if it can't make a change. Do I actually have sieve loss? We get out and we go back there and we do our foot by foot square and we don't see a unacceptable amount of loss, then we need to go ahead and we need to lower that sensitivity. We might just be asking it to do more than it's physically able to do, right? If there's no loss, how can it correct for it? It might be seeing chaff, corn cob, stems, whatever it is. It might be seeing that because their sensitivity is just simply too high. But there's more to it. We'll get into that a little bit more. How do we make background settings, and then maybe how do we use ranges to help make it a little bit more responsive too. But the first thing is, again, getting out and validating the issue and trying to adjust sensitivities to accommodate for it. If that doesn't work, then we'll get into some settings and ranges afterwards. Any other questions? Okay. So what we're going to do is I'm going to go ahead and I'm going to select this icon here on our 1200 to get into our harvest command settings. If it was a Pro 700, what you would do is hit the back button, and at the bottom center you see the automation tab, and that's how you get to where we're about to go through on these settings. So the first thing that we see here is our work condition. Do we know what work condition is for? Do we use work condition? What it's related to? Okay. So work condition is tied to your crop type. So in this one, we're seeing all the work conditions for corn. So all it allows us to do is kind of have these predetermined harvesting profiles for each crop type. So soybeans would have its own, wheat would have its own, and so on. So as you can see here in the corn setting, we have a second season and a wet right now. So let's say we were going ahead and we were harvesting our normal dry corn around that 15% mark, and then we got into some high moisture corn. What would we typically have to be doing once we transfer to a different harvesting bracket or moisture level? We'd have to find our sensitivity settings that work again. We'd have to find harvesting profiles that work again. If we're utilizing ranges, we'd have to reestablish new ranges, and so on. The main benefit of work conditions is once you find what works well for that current harvesting condition of that crop type, you can go ahead and save it. That way, every time you return to that general baseline, all you do is select that, and then you don't have to find your sensitivities, ranges, and harvesting settings again. You have an original set point to go to. So we could have one for dry corn, one for high moisture corn, one for different cob types of corn, and so on. That way we don't have to have multiple harvesting conditions set up. Does that make sense?
How do you save that then?
On the 1200, you just add new. In your 700, it's going to be through your ACS profile.
That's just setting the settings that are currently on there,
Yep.
or you have to tell it what to set?
So how currently set up?
Set it the way you want manually.
Save it profile.
Save it.
Exactly.
And then you turn the automation on and it'll start with those settings.
If you have a initial setting set to current setup, which we'll cover that in a minute. But yes, if we have one of our settings done correctly. Any other questions? Okay. You thinking that's a touch? Moving over, we have our strategy right here. So right now we see performance selected. What you're going to see under it is the best grain quality, performance, max throughput, and our fixed throughput. Does anybody remember what they run?
We run grain quality on everything.
What is that?
Well, mainly because of the seed beans, so we raise it. All
Yeah.
seed beans, so we do grain quality, and then just tend to like how it does with the beans, so we run
Yeah.
everything.
Yeah, absolutely. It's always going to be based off of operator and user preference to begin with. But there are a few things that maybe we aren't aware of what happens in the background when we do that, maybe some prioritizations the machine will take when we select performance or best grain quality. So we'll just take a minute and go over it, and then with that knowledge you can decide what you want to do. So best grain quality is, I think, pretty self-explanatory. Its main priority, its main focus, and what it wants to do is produce the best cane sample possible. So as minimal broken grain and as minimal mog as possible. Performance is the least amount of loss as possible. Max throughput is, we're going to do as much or as close to the target engine load all the time. So if you have it at 100, it will prioritize getting that load up over everything else. And then fixed throughput is fixed bushels per hour. If maybe you're trying to match an elevator of the trucks that are coming and going, that way your machine's running at a steady pace all day rather than running fast, stopping, running fast, and stopping. But moving back to our best grain quality, let's look at maybe some operational experiences we might have with it and things that it might prioritize in certain areas versus others. So let's say we're going along and we have the best grain quality selected, and our machine starts to see MOG. Okay, MOG, if you're not familiar, material other than grain, is getting high. So it's seeing it, it's sensing it, it knows that I have a MOG issue. So it decides to address that and fix the MOG. So what is the typical, what do we typically do to fix it? Well, we adjust the cleaning fan. We either are going to speed it up, or we are going to close our upper sieve probably, right? And what typically can happen after either of those changes result? Sieve loss probably, right? So let's say we do that, or the machine does that. It closes the upper sieve, and it starts to see our sieve loss go up. Okay, well it comes back and it starts to address the sieve loss, and now my MOG goes up. Well, now it has to make a decision. Do I accept a certain percentage of loss, or do I correct the MOG? With the best grain quality strategy selected, it will always choose to correct the MOG and accept a certain amount of losses, saying there are limiting factors because of this. So in some scenario, with best grain quality, it might be willing to accept a bit more sieve loss to maintain the tank sample. And the exact opposite can be said if we have performance selected. We have performance selected and it needs to decide, do I close the upper sieve and get a better grain quality, or do I open it to have less sieve loss? It will choose to open it to maintain your sieve loss. So I just want to keep that in mind when we're selecting it. Well, what are we really prioritizing and what is it changing in the background? So to understand that, we probably need to know what are we trying to harvest, what is the outcome here. So in your seed beans and things like that, absolutely your best grain quality is probably your best, because you have a higher dockage and you make more money by having a better sample, right? But if you're sending to, let's say, an ethanol plant on corn, where you have a higher percentage of MOG and broken grain you can send in, and it's simply about the more weight that I can get, right? Because the more pounds per acre I get, the more weight that I get, or the more money that I get. So why wouldn't I be willing to prioritize losses to capture more of my crop and accept a certain percentage of MOG and broken grain and get more value out of that? So you're just going to have to tailor it to what is my specific operations and what is the crop type that I'm doing. But for the most part, performance is probably what you're going to select, unless you're doing like seed and edibles and some unique crops like that that are brittle. But for the most part, my general recommendation is let's go ahead and let's start on performance, unless we're experiencing extremely poor quality with our variety. Any questions on that? So last thing we're going to see on the basic tab is our target max ground speed and our target max engine load. Do we know what those are related to? Does anybody here use feed rate? Yeah. So probably since we're not using it, we don't know what feed rate is, right? So feed rate is simply a automated ground speed control to maintain our engine load. So our machine will speed up or slow down to maintain our target engine load or get as close as possible. So normally speaking, let's say we want to run 5 miles an hour, that's our target ground speed we want to go, and we want to run feed rate. I like to see putting in about a 1 mile an hour buffer zone. So I would probably set my max target at 6 miles an hour. That way, let's say we're going along at 5, and we're doing beans that's yielding 70 bushels to the acre, and we hit something that drops for 50 yards to 30 bushels. We can power through that short, low-yielding section and quickly get back to our higher yielding and maintain the load. So that way we don't have a reduction in grain quality. And then with our target max engine load, I typically like to see that as close to 100% as we can. Again, we might have a different desired with our different crop types, but preferably no less than 95% because, well, how is my machine more efficient? How do I get the best grain quality out of a rotary machine? Keep it full. Keep it full. And we're going to do that by having our engine load as high as possible. Because if you don't know, the way our machine works is it's not the result of the corn getting hit by the rasp or the corn getting dragged across the concave. It is threshed by the corn hitting the corn. It's crop on crop or grain on grain threshing. So the more we have in there, the better quality threshing we're going to have. So we want to keep it as full as possible, and we'll do that if we're using feed rate by putting our max around that 100%. Does that make sense? Anybody here tried it with feed rate and experienced maybe every time I'm going 5 miles an hour. My target's at 5, but I hit it and I engage it, and I go down to 2 miles an hour every time no matter what. Yeah?
That or it's always slugging itself, speeding up and dropping back.
Did
Trying to
we-
keep it at 100%.
Did we know that there's 2 calibrations that go along with feed rate? No, most aren't aware. I'm not trying to pick on any specific person. It's just a simple reality that I've come to realize is we don't know that there are 2 calibrations of it. The first one is going to be our zero load count. So we gotta show the machine, well, what does it look like when I have no product in here, right? If it's all based off of percent engine load and maintaining ground speed off of that, we first needs to know what is my baseline, what is my start point of engine load with no product in it. So we're going to do our zero load cal. We're going to do this just simply by having our machine running, so threshing, feeding on, and header above max work height, stationary in the headland, and it's learning. This is what it looks like, no product in there. And it happens automatically once those conditions are met, and engine RPM up. Once those conditions are met, it'll do it automatically without you having to do anything special. The second one is going to be a calibration to learn what its target or its harvesting condition should look like. So that one is going to be us actually in the field running along harvesting, and if we want to go 5 miles an hour, we will run at 5 miles an hour, and then the feed rate engage button, which is the top right, it looks like a picture of an outline of a combine, a speedometer with an arrow pointing on it. You will go ahead and you will press and hold that for about 2 seconds, and what you'll see is your park brake actually turns into the feed rate icon, and that turns into an hourglass. When you see that hourglass visible, that means the machine is learning what is my current harvesting conditions? What does it look like? Because even though we set our target and our max right here, that does not mean that it is actually going to hit that when you engage it. That is setting your target as well as the max ceiling, but it doesn't know what it looks like yet and what we actually want to run at. So by doing that press and hold, we're starting a calibration sequence of what do my current conditions look like at my target speed. So if we do that at 2 miles an hour and 30% engine load, that calibration, and we want to run 5 miles an hour, what happens when we press the button to engage it if we calibrate it at 2 miles an hour? Right down to 2 miles an hour. It might slowly creep up, but the first thing it will do for sure is go to 2 miles an hour because that's where we did the calibration. So I typically see that a lot, and it's just simply because we didn't even know we were calibrating. We had no idea we were doing it because I had no idea there was a difference on the operation of feed rate from pressing it momentarily to pressing and holding it. I didn't know, and then that's okay. That's what we're explaining now is pressing and holding starts a calibration sequence which will change its target point. Another thing from an operational side that I want to go through is when we're out in the morning, what is typically on the ground? First thing in the morning. Dew. And then by noon, is there dew? So 5 miles an hour or 4 miles an hour, whatever ground speed we wanted to in the morning, might be 100% engine load. So let's say 100% engine load is 4 miles an hour. What would it probably be in the afternoon? Maybe only 80. So then there's 20% capacity we are leaving on the table. So we should probably do what? Do another calibration. And then by the afternoon, what's typically back again or what's going down? Sun's going down, we're getting some moisture back in. We should probably do what? Do another calibration. So typically what I like to see is let's do it at least 3 times a day, morning, afternoon, and night. And then I like to see it if we're changing crop types and varieties too. So if we're going from one field to the other, you know, we might have green stem, that's another justification for doing it. We're going from a dry corn to maybe it's 3% higher, 2%, or even 1% higher on corn from this field to that field. We should probably do it again on that change too. But at least 3 times a day. At least 3 times.
Because they don't remember, they don't know what.
Well, your harvesting condition is changing hourly at that point. So we're doing that calibration for the change in harvesting conditions. So if we're not constantly redoing it, it'll just go based off of your last calibration, which could be completely irrelevant for your current harvesting condition.
Your baseline though, your zero value of your MTJ, we comment that in the
Yeah, I would recommend, it's pretty easy, it goes in the background, so when you're warming it up, just go ahead, turn everything on and let it run in the background, and it's just happening. You don't have to press anything for the zero locale. Nope, you simply have everything on, engine RPM up, header above max work height with everything running, the zero locale happens.
Which does it automatically.
Yep, yep. The only one that you have to press and hold is when you're doing the target calibration.
But you have to press the button to get it to start the count.
The zero locale?
Yeah, you don't
No.
have to do anything.
You just have to have it raised.
Yep, it just has to meet those stipulations, those conditions first, and then everything will go.
And not with.
And yeah, stationary. So we want to just see what does it look like with zero locale. Yep. Which you can do that simply by hitting the shift and your auto header height or your resume button, and that puts it in the headland mode, which automatically takes you above your max work height, which we'll get into that in a little bit, talk about headland mode features. So feed rate works kind of uniquely with unloading on the go. So let's say we're running along and we start the unload on the go at 4 miles an hour. It doesn't disengage the feed rate. It simply pauses it at the current ground speed you're running at. So if I want to constantly run at 3 miles an hour while unloading on the go, I'm going to start the unload sequence at 3 miles an hour. The feed rate's going to pause. As soon as you stop unloading on the go, it'll resume and control automated ground speed again. So adjusting based off percentage. It'll disable feed rate. It's just like auto steer when you're running feed rate. As soon as you try and take control of the ground speed, it disables it. Just like on auto steer, if you touch the steering wheel, it disables it. Now, with feed rate, let's say you start and I accidentally start the unload sequence at 2 miles an hour. I'm not stuck with that and disengaging it. You know, I can disengage and speed up if I want to do the adjust on ground speed. It's a shift button. I believe it's header raise and lower, shift header raise and lower with a pause, and it'll do incremental adjustments to your feed rate. Best to refer to your ops manual on that one for sure which button sequence it is, but there is a shift feature that allows you to do incremental adjustments to your pause feed rate while loading on the go. If you want to leave it in feed rate rather than taking negative control of it. Does everybody know where their manual is? Any other questions on feed rate? Okay. So what we're going to do now is we're going to go into the advanced tab. So all these tabs that I'm going through on the 1200 here, if it was a 700, they would just be on the bottom. All the names and the references are exactly the same. Moving through, we had a question of once I have my work condition saved, is automation going to make a change off of that? The answer is yes and no. And I said it would be based off your initial settings. So this right here, you see the current setup versus the automatic. So if I have current setup selected, the answer is yes, because what it will do is make adjustments based off of how the machine is currently running. So let's say I took the machine into the field, I had my 25% moisture work condition selected, I was running, everything was working right, and well, I have automation, I want to use it, right? And I want to have the tank sample and the losses consistent for the incremental condition changes that I can constantly pressing buttons for. In that scenario, it would take your current work condition and how it's currently running across the field. Once you turn automation on, automation would then make changes based off of that. If we had automatic selected, regardless of what work condition we were doing, regardless of how we had the machine set up, as soon as we turn automation on with automatic, it will change all the settings to how we think it should be running. So our automatic default settings. So that's why maybe you've been running automation and I already had this thing running right, and as soon as I turned it on, it changed everything. Changed everything, and I don't like those numbers. The way you stop that from happening is making sure that it is on current setup versus automatic. Does that make sense?
Do you recommend starting it in the fall on automatic and then when you get it kind of fine tuned, and switching it to your current setup so it bases it off of?
Yeah, there's a few different ways that we can look at it. I find automatic works well, and I've had no issues with it because the result is going to be the same as long as we're setting up automation on those setups, like I said, of getting out, validating our losses, and checking the sample. The end result's going to be the same whether you have current setup or automatic. It's going to be user preference. So it comes into maybe the way that I do it is if I'm running a machine where I just want to showcase some new technology, get it started, and we're going to get into automation separate. There's times where I'll go in and I will set the machine up in manual, run it, and we're just going through some operational stuff and having them press buttons, getting used to the machine as a whole. And then once I have it running and everything's going well, I'll have this on current setup, then we'll turn automation on, and then let automation fine tune that setup. So there's a few variety of ways that you can do it. If you're trying to get comfortable with automation and the machine, you might just run automatic right off the bat because you don't have a predetermined settings or set points in the machine that you like. Now, if you've been running it for a while and you don't like the numbers automation is doing, you might go to current setup. That way the numbers are more familiar for you. Or you have it already working right and you just want it to fine tune. So it's going to be based off of preference. But automatic works just fine. Any other questions? Okay, we have threshing conditions here. I am not going to talk about this for the next 15 minutes until we get to the ranges, and then I'm going to beat it into the ground. But for now, just think about, do I run easy, do I run medium, or do I run high? That's all that I want you to think about right now, and then when we get back to it, see if you can remember. If not, I get it. Again, it's been 6-8 months since you ran it last. It's okay. The next one here is our adjust frequency. And this goes back into, well, what do I look for if it's not making a change fast enough? Adjust frequency is directly tied to how soon or how frequent automation will make a change once it has crested that trigger point. Again, it has to crest that trigger point. So we have low, medium, and high. Low is going to be about 40 seconds, medium is about 20, and high is about 2 seconds. So I know what everyone's thinking right now is, well, okay, I'm just going to do high. Hold on. Because the reality is, once we start coming down here, once we get past medium, these two look at a full set of filtered, unfiltered data, meaning it looks at the whole picture of what's going on for, let's say, a 2-minute recording. When we select high, even though it makes an adjustment in 2 seconds, it looks at filtered data. Meaning that if it recorded it, it was only looking at part of the picture. So if we have a foot-by-foot square of losses, automation with filtered data might only be looking at a small portion of it and making a decision based off that small portion it's seeing. So therefore, if it's only looking at, let's say, an inch-by-inch square in a foot-by-foot picture, it might see no sieve loss here, meanwhile sieve loss is scattered throughout that other area. So it might think, I don't need to make a change when it does, or it could be the extreme opposite. Maybe that small filtered section it's looking at has an unrealistic representation of high sieve loss. It makes a change for it that didn't actually need to happen. So the time that I would recommend going to high is when we have extremely variable harvesting conditions. So let's say we have a hill across the field. The top of the hill maybe has sunshade, the bottom of the hill has no sunshade, it's open. So moisture level right off the bat is going to be different, right? So maybe we have 18% beans to 12% bean on a 100 or so yard pass, which is pretty variable, right? It's pretty hard to compensate for it. And then we also have extremely varying yield conditions, which we always do from the top of the hill to the bottom. Usually less so on the top and more so high yields on the bottom, right? So already we have yield, we have moisture that are extremely variable. And then maybe we have some down conditions now that we introduce in there. So now it has extreme moisture, extreme yield, and it has down all in one pass. Things like that might be a justification for where we would go to high, because it's constantly going to be having to change throughout a very short period of time. Now in more uniform crops and more typical harvesting conditions, medium is where I'd recommend it. We're still getting a faster adjust time, but we're getting the full unfiltered data, meaning we're looking at the full picture, and the information or the justification behind it is better. Does that make sense? Next we have our feed rate sensitivity. So we have very, very low, low, medium, high, very high. My opinion is start on high. So go right to high. Very high can be a little bit overreactive, but I would just start on high. That's what I find works well for most conditions. You don't want to go too low, because if you go too low, then we have things like slug prevention that might not be there. If our feed rate is calibrated correctly and we have the settings correct, it should prevent us from having a slug. Unless, of course, we go from 5 miles an hour and then immediately hit this extremely green patch. That's a little bit hard to compensate for. Yes, that might justify taking over manual control on that one. Last thing here, this is unique for the 1200, is this range configuration tab. All it does is if I hit yes, you'll notice the range tab on the side disappears. If I turn it on, it reappears. This is just like maybe you found ranges that work well for you and maybe you're leaving for an hour or two, or you set it up and then you have somebody else who's going to come in and run it and they're a button presser and you don't want them to press buttons. You go ahead and hide it. Until they press that button, then it's back, and then at least you tried for a little while. Any questions on this part of our automation setup, some of the background settings? We're going to keep going through it, but these are your main settings that we got to get correct, just for the baseline of how we even start to have it work right before we even go into adjusting your sensitivities and trying to get the funnel fill correct, and so on. So I'm going to move down to sensitivities. This I'm just going to hit for like 2 seconds, because this is just where we can start. Maybe we have sensitivities we remember from last year, we didn't save a work condition, we can go ahead and adjust them right off the bat. Keep in mind though, even if we are trying to do a baseline of what worked well last year, or maybe we're taking sensitivities from one machine transferring it to the other, just because this sensitivity works well on this 8260 does not mean the sensitivities for this will work well on your other 8260. Each machine will be unique. They might be close, but they will be unique. So don't go ahead and say, well, this worked perfect on this one, and then not understand why it's not working well on the other. There's going to be differences between the machine, differences between the sensors, as well as the operator input. Moving down, we have our headland mode. How many people here use headland mode? Do we even know what headland mode is? We have one. What do we do with our headland mode? Yeah, so what do you have changed? Slow your fan down. Yeah, so when we get to the headland and we turn around, what usually happens? What? Well, why is that? Well, because we get to the end of it and we stop putting product in. As we stop putting product in, what happens to the load on the sieve? It becomes less, so therefore it's lighter, but our cleaning fan doesn't adjust for a lighter crop mat. So as it gets lighter, it starts blowing more out the back, and loss usually occurs on turnaround. So what we can do is we can have automated sequences that happen. So headland mode is a feature of being above max work height or hitting shift and header resume. And that takes you into headland mode, and you'll see if it's a 700, this A will turn to an H. 1200s, it just populates the H right there. So what I typically like to see is we'll just go ahead and take this down to a negative like 100 or 150. I don't typically mess with the pre-sieve, the upper or the lower sieve. And then What is that in front of my 90 right there? Minus. If I don't see that minus, what did I just do? Which results in an increase in our sieve loss. It actually accelerates the problem on turnaround. So just make sure when we are doing this, if we want to run these headband features, and we want to reduce something, it has a negative. If we want to increase it, it has nothing. Does that make sense? Typically what I like to see, again, like I said, is we'll just go ahead and we'll leave about 100 or 150 reduction on our cleaning fan on turnaround, which again, shift, then your header height resume, takes it to headland mode, and then all you do is when you turn around, you just hit it again, the resume button without shift, and it takes you right back to your cut height. And that's our turnaround sequence to run headland mode.
You do that every time you get to the end.
Shift, yep, shift, resume, and then once we're ready to cut again, we hit resume again.
Or just lift it above. the
Or
next.
lift it above. But if you wanted the automatic sequence, you get the shift and resume. There's no questions on that. We'll go down to my ranges tab, and this will be like my last main thing. It's not light, but it's my last thing. What is my ranges tab? What are we doing? What are ranges for?
Keep it from whatever, adjusting.
What?
Keep it from over adjusting one way or the other.
Yeah, so we can think about them as guardrails. We can think about it as guardrails or where the machine can make settings. So if you're not familiar with automation and what it actually does other than like adjustment sensitivities and it makes changes, the logic behind it is it wants to be as productive as possible. So in the relationship of the rotor, it's going to want to run as fast as possible while meeting the requirements the operator sets. So grain quality, threshing condition, and whatever outcome you say. But in it, what it's going to do, sticking with the rotor, is it's going to test any RPM between 300 and 450 to produce the outcome that the operator wants while being as productive as possible. Again, why it tries to run as fast as we want. So sticking with the maybe where we would use ranges on our rotor, let's say we're running along in the corn, and every time it just keeps going up to 450 RPM. But every time it does that, we see broken grain. And it knows it sees broken grain, and it's making a change. We haven't physically had to do anything until there's too much broken grain. As soon as it goes to 450, the funnel flow goes up, it triggers it, it slows the rotor down, and it's fine. And then like an hour or so later, it brings itself back up, and the process repeats. Well, why does it keep going to 450? Because every time it does, it introduces poor quality. So what can we do to stop it from even going to 450, right? Well, we can simply take this and reduce it down. Tell the machine, hey, when you're learning our settings and what setting works well to produce the outcome that I want, when you're doing those tests of anywhere from 300 to 450, you're no longer able to do that last 50 RPM. You can only test between 300 and 400 now. So when it tries to get its max productivity, its highest level of rotor speed to get that productivity is now 400. So it won't go into that last 50 RPM that you always saw producing broken grain outputs. So again, it's like producing guardrails. And when I say guardrails, I'm not talking about like cheap, flimsy ones that we could easily drive through. These are hard barriers. It will not go above 400 RPM. So if we want to say, well, and this is a soft line I want it to follow, keep in mind that if you put that to 400, it is at 400 for max. So if you have variability in the field where it might need to go up to that 450 on small pockets, it is no longer able to. So just keep that in mind. It will help stop it from overshooting or falling out of range sometimes, but you are limiting the test points automation can do to produce the outcome you want. Just keep that in mind. I do like using ranges, I am a fan of it, but we just need to understand what the potential downsides are. Because if we do that, and it goes ahead, and we save it here, and we're in it, and now we have unthreshed, or pods in the tank, or we have whatever it affects, even if it recognizes the issue, and it wants to fix it by speeding up the rotor RPM, that funnel fill will sit in the red, because it's no longer able to achieve that set point to fix that issue. Does that make sense? It'll identify it all day long, but with the ranges, it'll never be able to make the change.
what do you recommend changing it at a time?
I am
Small adjustments?
I'm a very big fan of being conservative when I'm doing range adjustments because I would rather have to make small incremental adjustments, let's say 5 times, rather than making 2 large jumps and overshooting and then coming back and doing 4 jumps backwards to get to the set point that I like. Because you might find if we're doing small increments, we might do 1 or 2, and then it's fine. And then at the same token, why would I jump 100 RPM and limit it to only being able to adjust 100, when if I do 50, it now can jump between 200, right? Why would I limit the machine if I don't have to? So I do small increments to bring it down, because I don't want to neck it too much, because then it limits the amount of set points it can do for the different harvesting conditions. Does that make sense? Something else I want to know is that a reset button. So if I go ahead and I'm messing around with it and I'm trying to see, do I like doing large jumps? Do I like doing small jumps? Does 300 and 400 work well? Does 200 and 500 work well? And I just want to simply test and figure it out, and I make that change, and it doesn't work well, but now I can't remember where I was that worked well from the factory. Just hit the reset. There's resets for each individual range, and then there is a reset for all the ranges. If you went through here and you messed with all of them, and you found that you just went crazy with it and you don't remember where any of it was at, you can reset all of it to factory through this reset too. So I'd like to bring that up because I encourage you guys, just like sensitivities, figure out, do I want to raise it 5%? Do I want to use the hot links? Do I want to use my ranges? And then if I do want to use my ranges, how much of it do I want to use? Press the button, make the mistake, because that's how you're going to learn how far I want to adjust it at a time, or what ranges I like to start at. There's the reset, takes it back to the factory settings. There's no harm. So make that mistake, right? Press the button. You don't often hear us saying that. Take advantage of it. Any question on ranges? Okay. Last main thing that will really heavily affect our automation is this work condition. So I asked you guys to think for a second, well, what do I run for my work condition, or threshing conditions? Does anybody remember? Where do we start? Easy, medium, hard, what do we run? Why?
That's what the name is.
Oh yeah. Right. And you also found the $100 bill in there, right? Well, why do we think medium? I think I know the answer, but well, it's right in the middle. I don't really know what threshing conditions are doing, so I picked the one in the middle because that's the safest bet. I'm probably getting the best of easy, probably getting the best of hard. Or we think that as we go through it, well, the toughest time my machine is ever going to run is when the threshing conditions are hard, right? This is the hardest my machine will ever have to work. So therefore, when I make that change, it's going to scrutinize the decisions it's doing a little bit harder because it's more critical because it's working harder, right? No. No. By actually selecting the middle and the neutral ground on this, we actually limited our machine. So what I want you guys to do here, and we'll explain it in a second, but we'll visualize it first, is go ahead and take note of my rotor speed. So my rotor can go 350 to 650 here, and you can go 0 to 8. I'm going to go ahead and I'm going to change this to hard. Maybe I adjusted my rotor speed, that's what I did wrong. But what happened with my K pins? So now what? If it could go 80 to 0 before, which 0 is the most amount of threshing passes, and 80 is 80% speed, so it's almost as fast as it can go. So less threshing passes, it can now go the most amount or 30%. That's 50% less. So if I'm in 15 or less percent corn, we'll just stick with the corn scenario, and I just made that change, what I did? I just turn my machine to a quarter of a mil pretty much, right? The reality too is this normally is 450 and this bumps up to about 400, 450 here. So it takes the rotor and gives it a narrow range on the high side as well, because in hard thresh conditions, it wants to run faster, or needs to run faster. So it limits what our rotor can do, and it limits what our cage vane can do. Because going back to what I said, what is automation doing when we tell it an outcome that we want? It's just testing, right? It's testing various settings to be as productive as possible and produce the outcome that you want. So when we did this, what did we do? We limited the number of tests we can do. By making this change, we're just changing predetermined ranges or limits on the machine, saying that this prop is hard to thresh. So when you are testing, figuring out which set point works well, don't test the settings that we would normally use in easy and medium threshing. Don't even test those. You're not allowed to even go in there, because I'm telling you it's not going to work right away. Does that make sense? So typically what I like to see is we're going to go ahead and we're going to leave this on easy, because why would I limit my machine if I don't have to? Right? Why would I limit it if I don't have to? Then what we'll do is, let's say we need to neck it down and we know for sure it is a hard thresh, we could use the hot links. Or we can go ahead and select here and narrow it down if we have to, and make our own restrictions on it. Because maybe we go to medium and it takes the cage vanes and it says you're no longer able to go faster than 50, but we know that we're not quite that extreme on the hard or medium thresh, and we want it to only go to, let's say, 67, 66, whatever it is. So we're not going quite to the extreme that we want, but we're still limited. That's the way that I typically like to do it, is leave it on easy and then neck it down, making our own custom ranges that way. The only time that I like to use the easy, medium, and hard is when we randomly happen into some hard thresh conditions and we need to make an adjustment fast, or we know for a fact we're going to be going into it and it's hard to thresh right off the bat. Most of the time, let's start at easy. Let's give our machine as much freedom to make changes as possible, and then impose ranges on it as needed afterwards. Does that make sense?